ideas of what we did in Unit 2. These are the things that are going to be on your final exam from Unit 2. So first thing on Unit 2 is going back and adding and subtracting those polynomials. When you add or subtract polynomials, all I have to do is combine like terms. It's a lot like adding and subtracting complex numbers. I combine my like terms and simplify. When you add or subtract like terms, all you do is keep the variable the same. You don't have to do anything to the variable because you're not multiplying it. So with this first one, we want to find the sum of the difference. Remember, sum is just add, difference is subtract. So when we add them, we want to locate our like terms, and we want to find the highest degree first, because we got to write it in standard form. So the highest degree I see is this fourth, to the fourth. So I'm going to have 8x to the fourth minus 3x to the fourth, which is 5x to the fourth. Then the next one should be 3, and I see a x to the third there. Because I don't have anything to combine with it, I'm just going to rewrite it. Alright, next should be squared. There's one, and there's one. So negative 8x squared plus 10x squared would be positive 2x squared. Alright, then we should have an x, and there's one right there. So because there's nothing to combine with it, it just gets rewritten. And the last thing are my constants. So 5 minus 11 leaves me with negative 6. Now, my answer is written from the highest degree down to the smallest degree. So make sure your answers are written in that standard form. Because I can't combine anything else, there's my answer. Now, when you subtract and you find the difference, you've got to remember you want to keep the first one, and you want to change the second one. When I say change, I mean change the signs. Because ultimately, you're taking that negative and distributing it out. So I'm going to keep the first one. And when I say keep it, I mean keep the signs the way they are. Now we're going to change the second one. So this negative 3x to the fourth becomes positive 3x to the fourth. That becomes negative 10x squared, negative 9x, and plus 11. Now it becomes just like the addition problem. I'm going to combine my like terms and write it in standard form. So my highest degree is that fourth. So 8x to the fourth plus 3x to the fourth is 11x to the fourth. And we're going to look for a third one. It's the only one, so I just get this rewritten. Then we're going to look for squareds. That combines to make negative 18x squared. Then we've got 1 negative 9x, so nothing to combine, just gets rewritten. Then we've got our constants. So our answer is in standard form. We can't combine anything else. So there's our final answer. Alright? When you multiply polynomials, you can either FOIL it or box it. Either one. With this first one, because we have a monomial times a binomial, I'm essentially just going to distribute. So everything in that parentheses gets multiplied by 2x. And I can't combine it anymore, so there's my final answer. Alright, the second one, you've got 2x to the plus 5 squared. That means 2x times itself twice. It's the same thing as if you had 3 squared. That would mean 3 times 3. 3 twice. So now I can either FOIL it or I can box it. Boxing it would look like this. I have a 2 by 2. And I fill in my box. Then I'm going to look for my like terms. Then I write it in standard form again. If we FOILed it, first outer So we've still got like terms right in the middle. And there's my answer. So either way, boxing or foiling, you're going to come up with the same answer. Just make sure though that when you see that, that means to do it twice. So take 2x plus 5 times 2x plus 5. Alright, the last one. We can foil it or box it. I'm going to go ahead and just foil it. Outer, inner, and last. Then we've got like terms in the middle again. Next thing we did was divide polynomials. To divide polynomials, you can either do synthetic division, as long as that has a coefficient of 1, or you can do long division. Because we're going to have to do synthetic for something else that we're going to talk about, I'm going to go ahead and just do synthetic on this one. So with synthetic division, as long as the leading coefficient of this is a 1, I can do it. So the first thing I do is I take the opposite of that right there. So negative 2. Draw the box. Then I look at this, what's being divided, and I just want the coefficients. So the numbers in front of the variables. So 1, negative 5, and 3. Because I have a trinomial, I've got all 3 terms. Everything is accounted for. All my exponents are there, so I'm good to go. First number comes down. Anything on the outside gets multiplied. Anything on the inside gets added. Alright, everything in that last spot right there is considered my remainder. Alright, so to write my answer, I drop 1 below that squared. The highest degree to write my answer, I drop 1 below it. So 1 below an x squared would be an x. Then I just fill in. And I write my remainder over what I'm dividing by. Alright, the next one. For this one, I can't do synthetic because I've got a 5 right there. I don't have a leading coefficient of 1. So for this one, I have to do long division. Alright, so first thing I'm looking at, what can I do to that 5x to make it look like 5x cubed? The only thing that will work is an x squared. So now, with an x squared, I'm going to distribute it back out. Now my goal was to get rid of that 5x cubed. If I try to get rid of it now, it's not going to go away. So that's when I have to go back and change all my signs. Now I want to make 5x and negative 15x squared go away. So to go from 5 to negative 15, I need a negative 3. To go from x to x squared, I need an x. So that's going to get multiplied back out. The way it is not going to go away, so I got to change my signs. And I'm going to bring 2 down. So now I'm looking at 5x and negative 5x. Only thing it needs is a negative 1. Multiply that back out. Change my sign. Oh no. That should be a positive. So that's a positive. Wow. So now I can change my signs. So now everything cancels out and I don't have a remainder. So my answer is that, with no remainder. polynomial, you either do the x method or you do the quadratic formula. Ideally, because it's just factoring and not solving, you want to just do this. So to factor this one, I want to multiply to get 32, add to be negative 12. So because I'm multiplying to be a positive, adding to be a negative, both of my numbers are going to be negatives. So to write out my factors, because I'm just factoring it, it's going to be x minus 4, x minus 8. And I'm done. I don't have to solve it, I just factor. When you see binomials, like 50x squared plus 75x and 3x cubed, so on and so forth, the first thought needs to be a GCF. 50 and 75 have a 25 in common. If you did not see that, you automatically saw a 5. Then you have an x squared and an x, I can take out an x. That leaves me with 10x plus 15. Now, 10 and 15 still have something in common. I can still take out a 5. So that means I'm not done at this point here. I need to take out another 5. Meaning my greatest common factor is in fact a 25x. Alright, the next one, I can take out a 3 and I can take out an x squared, which leaves me with that. Alright, the last one, 2x squared, 12x, and 16 have a 2 in common first. Factor that trinomial. Which is 4 and 2. So bring my GCF down. Write my factors. And I'm done. Okay, the next thing we talked about in Unit 2 was the factor and remainder theorem. A polynomial f and a factor of f are given. Factor f completely. So here's my polynomial, and here's one factor. So what you should see is that your highest degree is a 3, which means I should have 3 factors. So to find my other 2 factors, I'm going to use the one factor that's given. I'm going to do synthetic division on it. So take the opposite. Because I have 0 as a remainder, I proved that x minus 5 is in fact a factor, which it should be 0. If it's not 0, we've done something wrong, we need to go back and fix it. Now we've got this trinomial here. So now I want to go back and use my x method to find my other factors. That'll give me 11 and 3. So, we said at the beginning of this problem that we should have 3 factors. One of them is this. The other one is this. The third one comes from the problem that you were given originally. So don't forget to write that original factor down, because it is a factor. Okay? Next one. My suggestion would be to pause it here, try it on your own, and then go back and check your answer. So because you're given that polynomial and you're told negative 2 is a factor, I got to go back and think about what that means in terms of how my factor looks. So that means there's my factor, and negative 2 is a solution. So I'm going to use negative 2 in my synthetic division. So now I've got 4x squared, no x, minus 25. So to factor that, that, I got a difference of squares. So there's two of my factors. The third one comes from there. There's all three of my factors. Okay? Then we talked about the rational root theorem. This is where you list out any possible factor for that polynomial listed. So I need to find P and I need to find Q. All the possible factors for P, all the possible factors for Q. So the first thing I'm going to look at is Q, which is 3. Remember, it goes backward from Q to P. So the only two things that can make a 3 would be a positive and negative 1 and a positive and negative 3. And don't forget your positive and negative. Then we're going to try to do P, which is 8. We've got 1, 2, 4, and 8. Don't forget the 1 and the number are always factors. So now to list out my possible factors, because all we're focusing on is possible, is I'm going to put every P over every Q. So every P over every Q. Now you would want to simplify. So plus and minus 1, third, so here is my list of possible factors. On your test, all you're going to be asked is to list the possibles. So for the next one, you got 5 and you've got 10. So you've got plus or minus 1 plus or minus 5, and that's Q. And you've got all those are your P. So you're going to put every P over every Q and list out your answers. Alright, the last thing in Unit 2 is your end behavior of your graph. This is the only characteristic from polynomials that we need to focus on. The end behavior is the direction that the ends of the graph are going. So, first thing we got to find is that highest degree, the highest exponent in our polynomial. That tells us what our ends are going to look like. So if you have an even degree, 2, 4, 6, so on and so forth, your end behavior is going to go in the same direction, whether it's both up or both down. To figure out which end direction, you're going to look at that leading coefficient. The number in front of that variable with the highest degree. If it is a negative leading coefficient, both of your ends are going down. If it is a positive leading coefficient, both of your ends go up. If you have an odd degree, 1, 3, 5, 7, so on and so forth, your ends are going to go in opposite directions. If you start high and end low, that means you have a negative leading coefficient. Start low and end high, you have a positive leading coefficient. So, last thing, if I'm given this first part, 5x to the third, the only thing I care about is that number and that number. The 3 tells me I'm going to have opposite directions. Because that leading coefficient is positive, I'm going to start low and end high. So it would look something like that. Alright, the next one, you've got another odd, so you're going to have the opposites, but this time you have a negative in front. So I'm going to start high and end low. Think of it as you're starting out positive and you're ending that sign of negative. Alright, the next one, you've got your even degree. And your leading coefficient is positive. So it's everything is positive. The next one, you've got an even degree. So they're going in the same direction, but it's negative, which means it's been flipped. It's been reflected.